Today we're continuing on our detour. We took a separate turn, right, to take a little break away from Eureka Math, which is our normal math book, and take a little detour into Go Math Land. Yesterday we did Go Math lesson 11.1, which is all about classifying polygons. To remind ourselves to, get our brains, wake our brains up a little bit, turn to your math partner right now and explain to them what a polygon is and how you can classify them, how you know what they're named, and what's the difference between a regular one and a not regular one. Go. Today our learning goal is going to be similar. We're going to be classifying, sorting, and arranging different types of a specific polygon. We're going to be talking today about triangles. How many angles does a triangle have? How many sides? How many vertices? 3. We're going to be taking a closer look at their sides and their angles to see how we can sort them into different types. If you look closely at the Epcot Center Spaceship Earth building, that's that big round building in Florida, you're going to see a pattern of triangles. Do you guys see triangles here? Yeah. And so I highlighted one in blue. Oops. Here it is. And if you look at it, it tells you that the pattern has 3 congruent sides. How can I show that those 3 side lengths are the same? I could put a number. I could say 10 feet by 10 feet by 10 feet. Or could I use a mark? Yeah. What can I do, Supan?
Put a line.
Yeah, as long as I put the same line through it, it shows that they're congruent. Now, it has 3 acute angles. From your previous math learning, you should know what the word acute means, but if you don't, we'll talk about it, okay? We're trying to figure out what kind of triangle is outlined. Let's keep going. In order to help us answer this question, we're going to complete the following sentences. The left side of the chart helps us classify triangles based on the lengths of their sides. Okay, so here we can see a triangle that has sides that are each 3 inches. They showed you in 2 ways that they're congruent. Do you see how they have the marks and they have the labels, right? So this is called an equilateral triangle. Everyone say equilateral.
Equilateral.
Okay, how many congruent sides does it have? 3. So an equilateral triangle has 3 congruent sides. Go ahead and fill that in. Now, in the middle, let's take a look at this triangle. I see that I have 2 sides that are congruent. Is the third side congruent? No, because I have 2 sides that are 3 inches and 1 side that's 2 inches. That's not congruent. Only 2 of them are congruent. That's why, if you look closely, only these 2 have the marking. Does the 2-inch side have the same marking? Because it is not congruent. So, an isosceles triangle is the kind of triangle that has how many congruent sides? 2. Go ahead and fill that in. Let's take a look at this last triangle down here. We have one side that's 5 inches, one side that's 4 inches, and one side that's 3 inches long. Are any sides congruent?
No.
Are there any markings there that show that there's any congruency? No. So a scalene triangle has 0 congruent sides. So keep in mind that these 3 terms that we just talked about on the left-hand side, they deal with the side lengths. Did we worry about the angles at all? No. So there's 2 different ways you can classify triangles. One is by looking at how long their sides are, okay? And if you look at and analyze how long their sides are, you can sort it into 1 of 3 categories. It could be equilateral, isosceles, or scalene, okay? So in your notebook right now, I want you to write side lengths. And then in your own words, explain how you know if a triangle is equilateral, what it means to be isosceles, and what it means to be scalene. There's another way we can classify triangles, and that's by looking at the measures of their angles. So before we were looking at just the side lengths. Now we're only going to look at the angles, okay? So when you're ready with your notes, look back into your packet. The first one is a right triangle is one that has exactly one 90-degree angle. Do you see how this angle here is 30 degrees, this angle is 60 degrees, but this angle is 90 degrees? Remember that this square symbol right here means 90 degrees, means right angle. So a right triangle has one 90-degree, or we call it a right angle. So if a triangle has one right angle, we call it a right triangle. Now, take a look at this second triangle. Its 3 angle measures are 75 degrees, and 30 degrees. All 3 of those are less than 90. We call acute angles, acute, means less than 90 degrees. So if the triangle has 3 angles that are all less than 90 degrees, all 3 of those angles are what kind of angles? Acute. So an acute triangle has 3 acute angles. Remember, acute means less than 90 degrees, less than a right angle. Okay? Finally, an obtuse triangle has 1 obtuse angle. Obtuse means greater than 90 degrees. So when we look at angles, we see if they're bigger than 90 degrees or less than 90 degrees. Okay? Which one of those angles there is obtuse?
130 degrees.
Very good. So we can see that 130 is bigger than 90, so that is the one obtuse angle. This type of triangle outlined in the pattern can be classified by the lengths of its sides. It told us that it has 3 congruent sides, which means it's what kind of triangle? Equilateral. Good. And it has 3 acute angles. So that means acute, by the way, what does that mean again?
Smaller than 90 degrees.
Is less than 90 degrees. So what kind of triangle is it? Acute. So you can see that this triangle right here, because these 3 angles are less than 90 degrees and all 3 sides are congruent, it is an acute equilateral triangle. We can classify it from each category: side lengths and angles. Looking at these triangles, we can notice that all of the angles, by the way, how many angles did we add each time? 3, because triangles always have 3 angles. 3 sides, 3 angles, 3 vertices. So when you add up the 3 angles of a triangle, they always add up to 180. So what happens if I didn't tell you that this one was 75? Could you figure it out?
Yeah.
Because I could just add 75 plus 30, which is 105. And then I could say, well, I know this missing number needs to help it add up to 180. So I could do 180 minus 105, which is 75, which indeed, of course, as we know, is the angle. Okay? So you can use this knowledge to help you find missing angles of a triangle. Do you see that? Great.